students, welcome. So in this chapter we are going to discuss about rigid body dynamics. First of all, we will be understanding what is the rigid body. In this lecture we will just understand what is the rigid body. So if you take different kind of bodies, some bodies will have fixed shape. So like for example, if you are listening this lecture through a any device, that device will have a fixed shape, so that you can say that this is a rigid body. Yes. In the same way, if you take another example, like if you take two blocks which are connected through a spring, so then you cannot say that this is a rigid body. You can define a rigid body like this, that objects that doesn't change their shape. So these objects are called as rigid bodies. We can simply define rigid body like this. Okay, and like here I am taking this example of a object of a block. Now if you apply some force on this block, so then it will not change its shape, right? It will remain there itself. But if you take another example like this, here you apply some force, so then these objects will change their shape. So this is not an example of rigid body. We cannot say that A and B, which are connected through this spring, they are a rigid body. They are not a rigid body, right? We can say that this system is a non-rigid system or non-rigid body. Okay, now let's take one example and let's try to understand it. What will be the implication in the physics if there is something rigid? So I am taking this example that there is any kind of shape, and there are different points on this, point 1, 2, 3, 4, 5, so on. Now if I am saying that this is a rigid body, then the distance between 1 and 2, or you can say that the relative position of the 2 with respect to 1, with respect to time, it will not change. It will remain constant. The magnitude of the relative distance will remain constant. It is not going to change because the shape is not going to change. That's why the points will not travel with respect to one another, right? So this is the rigid body. So you can define it like this in another way, and you can also use this in the physics. You can say that the relative distance between the 2 points or 2 particles of the rigid body is always constant. You can say like, okay, now because r21, the magnitude of a relative distance is constant, so if we differentiate the magnitude, constant differentiation is 0, right? That's why there will not be any velocity of a point on the rigid body with respect to another point on the rigid body in the perpendicular direction. I think you understand, right? Because relative distance is not going to change. That's why r21 will not change, r21 magnitude will not change. And if we say that r21 magnitude will not change, then there should not be any relative velocity in the direction of line connecting 1 and 2. Okay, so this is about the rigid body. So it means if you take a body, again I am drawing it, let's take a unusual shape of rigid body, any kind of shape. So this is a rigid body. There are 2 points, point 1 and 2. They cannot have any velocity in the direction of line joining the point 1 and 2. They cannot have any velocity. It means, but still point 2 can rotate with respect to point 1. Yes. So that's why in a rigid body, if there are 2 points on the rigid body, so second point can do the circular motion or the rotational motion with respect to the another point, right? Let's say if we are taking this point 1, point 2, and point 1 is on the axis of rotation, point 2 is rotating with omega with respect to 1, then the velocity of the 2 will be omega multiplied by r21, right? And v1 is 0, but v21 if we calculate, that is v2 minus v1, that will be equals to omega multiplied by r21, but that total velocity will be in the perpendicular direction of line connecting the 1 and 2. It will not be in the direction of the line connecting the 1 and 2. It will be perpendicular to that because the shape is fixed. So this is the physical, this is the implication of this rigid body in our physics. So we can say that there will not be any relative displacement in the direction of line connecting 1 and 2. Okay, so this is how we define a rigid body. So this is the lecture about the rigid body.